Hello everybody, I hope you're doing well. Welcome back to another video in our Introductory Calculus playlist. So in the previous video, we have covered a brief introduction to special limits. Namely, we have proved that the limit as x approaches 0 of sine x over x equals 1. So now that we have this limit proved, right, what are some other special limits, one might ask? And today in this video, we're going to cover two special limits. The limit as x approaches 0 of cosine x minus 1 over x. And we're also going to cover the limit as x approaches infinity of 1 plus 1 over x raised to the x. All right, so in the interest of time, let's jump in. Okay, so let's work with the first limit. We want to prove, let's make some room here. So the first limit we're going to prove is the limit as x approaches 0 of cosine x minus 1 over x. So we want to prove this limit. Now, if we use our original limit techniques, we'll see that when we plug 0 in for x, right? Cosine of 0 is 1 by the unit circle. 1 minus 1 is 0. And then you're having a 0 in the denominator. So you'll have a 0 over 0 situation. And from first glance, we don't know the limit as x approaches 0 of cosine x over x, right? And we can't separate this fraction out, right? So we're kind of stuck at what's left, right? And maybe a step that's left we can try is, what if we can kind of change up the numerator and the denominator so that we can convert the limit into a form that, avoids this 0 over 0 scenario. So we can try that. So you might recall from the first video, we can try a technique called the conjugate, right? So let's try that because this might be an inkling you might have. So we multiply this by the conjugate of cosine of x plus 1 over cosine of x plus 1. So we're not changing the value, right, since we're multiplying on the numerator and denominator by the same amount. So what do we have here? Well, we have the limit as x approaches 0 of cosine squared x minus 1 over x multiplied by cosine of x plus 1. Okay, so what does this mean? So what is cosine squared x minus 1? Well, you might recall, right, that we have this identity right here, right? We've established from the unit circle video that sine squared x plus cosine squared x equals 1, right? Now, we want to get into cosine squared x minus 1 form, right? So what we can do is we can kind of bring the terms around. We can do some, switching of terms. So we can bring the 1 over onto this side and then bring the sine squared x over. So you'll have cosine squared x minus 1 equals negative sine squared x. And because we know this fact, we can kind of solve the rest of the limit. So this will be equal to the limit as x approaches 0 of negative sine squared x over x multiplied by cosine of x plus 1. Okay, we're almost done, right? So now if we look at this form, right, we know sine of 0 is 0. But if we plug 0 right now, right, we're going to have this state, we're going to get a 0 over 0. So what's left to do? Well, let's move down a little bit. Okay, so what can we do here, right? So we have the sine squared x over x multiplied by cosine x plus 1. Well, if you recall from what I've said earlier, right, we do have one more thing in our arsenal, right? We know that the limit as x approaches 0 of sine x over x equals 1, right? So I think it might be a good idea to take advantage of this fact here. I'm going to like star this because this is a fact that we've established from the previous video, and this is going to come to our rescue. So what does this mean for us, right? Let's try to use this starred fact right here in solving the limit. So this will be equal to the limit as x approaches 0 of sine x over x, right? So I'm just kind of separating out the sine x over x term because we can separate limits by products via the product rule of limits. So we'll have Okay, so now that we have this form, right, we can kind of break the limit into individual products, right? So we'll have limit as, so this expression here essentially becomes the limit as x approaches 0 of sine x over x multiplied by the limit as x approaches 0 of negative sine of x over cosine of x plus 1. So we know here, right, this term right here, right, is going to evaluate to 1. Why? Because this is the fact we've established in the previous video. So let's move down a little bit so we can kind of illuminate that fact in a clearer way. So let's get our pencil back. Okay, so we know that this part is going to be a big fat 1, right? Because we know the limit as x approaches 0 of sine x over x is going to be 1. So now all that's left is to solve this limit right here. I'm going to use yellow to encapsulate that. So we want to solve this limit in yellow. And now if we notice we plug x equals 0 into this expression, we know sine of 0 is 0 from the unit circle. But fortunately, we know cosine of 0 is 1. So we're going to have like 0 over 1 plus 1. So this is going to be 0 over 1 plus 1, which is going to be equal to 0. So 1 multiplied by 0 equals 0. Hence, the limit as x approaches 0 of cosine of x minus 1 over x is nicely evaluating to a big fat 0. Alrighty, so we've have this fact established. So now that we have this established using the conjugate, we can move on to solving for the next special limit. Namely, we want to figure out this limit right here. I'm going to use green so we can do some work down here. We want to figure out this limit. The limit as x approaches infinity of 1 plus 1 over x raised to the x. Okay, so when we're solving this limit, right, there's a couple problems, right? If we plug infinity in for x, right, we have that 1 over a big number is going to approach 0. So this inside term here is going to approach 1, right? Because 1 plus a number that's very, very small is going to approach 1, right? But then you're raising x to a large number, right? So this inside term is essentially a number very, 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 very close to 1. So you can imagine this term to be like 1.000000001, and this x to be like a really huge number. So you can imagine this to be something like, I don't know, 10 to the 100, right? And we want to figure out what is this very, very close number to 1, but higher than it, raised to a large exponent. Does that necessarily approach 1? And the answer can be, and we don't have an answer to this right now, right? At least from our knowledge of limits. But what we can do is we can try playing around with this function and kind of seeing what happens, right? So the way we're going to do this is we're going to try exploring with different values, right? So this is a good opportunity for you to get your calculator out and follow along here. So let's try different values of x and see what happens when x gets really, really large. And we can see if this limit is really approaching a number that we know. All right, so I'm going to have a table right here. So let's say we plug x equals 10. So we plug this into our calculator, right? We will see that this is 2.5937 approximately, right? Okay, so this is kind of what x equals 10 evaluates to, right? Let's go a little bit bigger. Let's try 100, right? If we plug 100 in to this function, right? So 1 plus 1 over 100, quantity raised to 100, right? That's going to be 2.7048. Let's try plugging in 10,000, right? Let's keep going bigger and see if we notice something. This is going to be 2.71814. Okay, cool. Let's plug in 10 to the 6, so we're going to plug a million in. If we plug a million in, this will be 2.71828. And then lastly, let's plug another larger number than a million. Let's go to 10 to the 8th. So this will be 2.7182817. And as you see here, right, as we plug in super, super large numbers for x, right, even this limited set of data, right, does this number look a little bit familiar to you? And if you remember from algebra class, you will notice that this number of 2.7182817, right, this number seems to be like the number e, right? So e is the Euler number. And maybe a suspicion might be this limit might be approaching the number e, right? Which is like 2.71828. I don't remember all the digits of e off the top of my head, but yeah, you see that this limit is going to approach e. And now you might be like, well, Karthik, we plugged in a limited set of data and you're kind of guessing that it's going to approach e. How do we know for sure that this function is going to spike up, right? And if you look at, and what we can do to convince you on that is let's draw a approximate graph, right? Notice that I'm using the word approximate graph instead of like a perfect sketch. So the graph actually, if you draw it out and kind of plot these points, you can probably try plugging bigger and bigger numbers. Maybe you can try plugging more numbers to see if you can get some data. But I'm going to scale my axis right here. Then I'm going to have the x-axis kind of right here. So what's happening is that you are going to be approaching E. So when we plugged in 10, right, we got like 2.5, right? So we were like, so let's say this was like 10, 20, 30, blah, blah, blah. So we're scaling by 10. So 2.5 is like a, I'm going to use a different color to sketch the points out. So let's use yellow. So maybe 10 is about here. And then when we had, 100, right? 100 was 2.7, right? So 100 would be maybe somewhere here, right? 2.7. This is just rough sketching, right? And then we had, let me erase these points here. Okay, so we have, okay, so we have 2.7, and then 10 to the 6 is like somewhere, maybe let's say it's over here, 2.718, so on and so forth, right? So what's happening is you're going to have some graph that's going to be kind of like asymptoting like that, right? And with this like asymptote, right, you see the graph is going to plateau. This E would actually be whatever this, it'd be like whatever this line is. So you see that like the yellow is kind of like our function growth, right? When x gets super, super big, right? And the blue line is kind of what are we plateauing at, right? So this blue line is y equals e, and the yellow is going to be like our function growth. So I'll label that. So we see here that we're kind of plateauing at e when x gets really, really large. So hence, we can conclude that the limit as x approaches infinity of 1 plus 1 over x to the x will equal e, right? Now, for the skeptics out there that might be like, hey, Karthik, you didn't really prove that the limit was approaching e, right? Just like you did in the previous limit. And you're right. I totally admit that I did not do a complete proof right now, but I will promise you that when we get later into the playlist, we will definitely come back to this limit and do a more formal proof as to why this limit actually approaches e. But right now, it's good to like, know that sometimes with some limits that you don't know how to solve, it might be helpful to experiment around and see if you notice anything about the function or notice like a pattern, right? So that's a wrap for this video on special limits part 2. In the next video, we'll be spending time on practicing special limits and evaluating limits using the facts that we've proved in this video and the prior video. So till next time, I will see you in the next video. Don't forget to like and subscribe, and please feel free to leave any comments as to how we can make, this playlist more accessible for everybody who's trying to learn or refresh calculus. Have a good rest of your day.